Hello, dear students. Let us study the various models of our structure of atom. So, the first model that was given or was proposed by the scientist J.J. Thomsons, and that is what it is known as the J.J. Thomson model. So, the question we have that explain the points of Thomson model with which two example can we compare. Say it is similar to Thomson models. Write limitations of the Thomson model. So here we need to discuss the Thomson model. Then we need to compare this Thomson model with two everyday example or practical example so that we can understand the Thomson model well. And then we need to understand about the limitations of the limitations of the Thomson model, and after that we need to study about the model. So let us move forward and understand it. Let's see the various points of Thomson model. So points of Thomson model. Thomson proposed that an atom consists of a positively charged sphere and electrons are embedded in it. Embedded means they are pushed inside it, or they are available inside it, or they are present inside it. The negative and positive charges are equal in the magnitude, so the atom as a whole is electrically neutral. So my dear students, these are the 2 points by Thomson model. He says that an atom consists of a positively charged sphere and electrons are embedded in it. So you can see that this black part is a positive charge. This is positive charge. Which is represented with the black color. And you can see that electrons with the negative charge, they are embedded in it. The negative and positive charge are equal in magnitude, and so the atom as a whole is electrically neutral. Model proposed by Thomson is similar to the Christmas pudding. Now, how is it similar to the Christmas pudding? Let us see. The electrons in the sphere of positive charge are like the nuts or dry fruits in the spherical Christmas pudding. So if you compare this Thomson's model with the Christmas pudding, in the Christmas pudding, the chocolate part is positively charged and the nuts or dry fruits which are embedded in them are like negative charge. If you are not able to understand it, we will have discuss one more example. Model proposed by Thomson is to be similar with the watermelon. तरबूज आपने खाया होगा. So this watermelon has got two parts. One is red part and there are black seeds available which are embedded into the black part. The same way, like watermelon, the positive charge is like the red edible part and the negative charge is like the seeds which are black in color embedded into the red part. So Thomson's model can be explained by using the two examples, either the example of Christmas pudding or the example of watermelon. Thomson model can explain that atoms are electrically neutral. So that was the success of the Thomson model. That was the biggest success of the Thomson model, that Thomson model was able to explain that the atom is electrically neutral. Now let's look at the limitations or the drawback of J.J. Thomson's model. So we are going to study about the limitation or drawback of the J.J. Thomson model. The results of various experiments carried out by the other scientists could not be explained by the Thomson model. This is the major problem with the Thomson model, that after Thomson proposed a model, many scientists have done various experiments, and these experiments were not matching to the standards of Thomson model or are not matching with the idea that is given by the Thomson model. Let us look at the next point and understand what is that. Let us see what was the Rutherford's what was Rutherford interested in knowing and what did he do? So there was a scientist, his name was Rutherford. He wanted to know something about the structure of atom, and to know more about the structure of atom, what did our scientist Rutherford did? That let us see. Rutherford was interested in knowing how electrons are arranged within an atom. So Rutherford arranged an experiment in which fast moving alpha particles are made to fall on the gold foil. So Rutherford did one experiment in which he has allowed the fast moving alpha particles to fall on the gold foil. Why did Rutherford select gold foil? Why Rutherford has selected, or why Rutherford chosen the gold foil, my dear students? Let us see and understand it. Rutherford selected a gold foil because he wanted as thin a layer as possible. So he wanted a very thin layer. So he wanted to get the maximum thin layer, and the thinnest layer is possible with the element gold, and that is why our Rutherford has selected the gold foil. The gold foil of Rutherford used was around 1000 atom thick. So the gold foil which was used by our Rutherford was around 1000 atom thick. Now we want to study about the alpha particles. So describe alpha particles. We want to study about alpha particles. What was that and how was them? So let us study about the alpha particles. Alpha particles are doubly charged helium ions, He plus 2. You can see the double charge or plus 2 charge. So that is what they are known as the alpha particles. Alpha particles are having plus 2 charge. That means they are doubly charged. And helium ions, as they have charge, they are known as ions. So we can say that from helium, the 2 electrons are being removed, and thus the helium ions are formed, and that is what it is, the nucleus of also helium. So alpha particles are actually doubly charged helium ions, or alpha particles were the nucleus of helium ion. Alpha particles has mass of 4u. You can see that 2He4. So when we write 4, this represents the atomic mass. And thus we can say that alpha particles were having the mass of 4u, or 4 unified mass. Mass is there with the alpha particles. Fast moving alpha particles have considerable amount of energies. So those alpha particles which are moving very fast, or fast moving alpha particles, they have some energy, or their energy was considerable amount of energy was present with the alpha particles. So we should understand the alpha particle with these 3 points. First, alpha particles are doubly charged helium ions, or alpha particles are helium nucleus. Second, alpha particles have mass of 4u, or the mass of alpha particle is 4 unified mass, or 4 atomic mass unit. And then fast moving alpha particles had the considerable amount of energy. They possess some energy. What did Rutherford expect from his experiment? Now, Rutherford did an experiment of falling this alpha particle, or fast moving alpha particle, on gold foil. What was Rutherford's expectation? What did he thought? What would happen? So let us see what he was expected. Rutherford expected that alpha particles would be deflected by subatomic particles in the gold atoms to a small angle. He expected small deflections. So see, suppose this is the gold foil. This is the gold foil. Our Rutherford thought that if he will incident these alpha particles, or the alpha rays, on this gold foil, he was expecting that they will move in some other direction. And this is the angle of deflection. Let us say this is theta, or we can say it as a angle of deflection and our Rutherford thought that he expected small deflection or small angle of deflection. So he thought that these alpha particles, instead of moving in a straight line or moving in any other manner, he thought that these alpha particles will go in this way and their path will be changed. So he was expecting the deflection and he was expecting a small deflection. Once again, Rutherford expected that alpha particle would be deflected. Deflected means they will not go in their own direction, but they will change their pathway and go in some other direction. So instead of going in this direction, they may have some deflection. The angle of deflection is this, and this is what it is. This is what he was expected, that there will be a small angle of deflection. So he expected a very small angle of deflection from his experiment. What did Rutherford not expected? Why did Rutherford not expected large deflections? Why this deflection that Rutherford has not expected such a large deflections? Why did he not expected the large deflections? Why this angle is not so big? Since alpha particles were much heavier than the protons, Rutherford did not expected a large deflection. So alpha particles are very heavy. They are even heavier than the protons, and that is why our Rutherford had not expected the large deflection. Now let us describe the Rutherford's alpha particle scattering experiment. Write the observations. Describe Rutherford's experiment and write the observations. So first we need to understand the Rutherford's experiment, and then we will look into the observations and all the other things. So let's have a look to this figure where we can study about the Rutherford's experiment. Before we look into the figure, I think it's better that we read the text about the Rutherford's experiment. So let's have a look to this. Let's study about the text. For Rutherford allowed fast moving alpha particles to fall on 100 atom thick gold foil. The following observations were made. Number one, most of the fast moving alpha particles passed straight through the gold foil. Second, some of the alpha particles were deflected by the foil to the small angle. And then the last one is, and the last observation was, surprisingly, it was surprised that surprisingly 1 out of every 12,000 particles appeared to rebound. So now let us see what this experiment try to tell us. Let us have a look to this so that we can understand it better. Just have a look to this figure. This is the figure for the scattering of alpha particles by gold foil. So you can see these particles which I have shown you in this manner. They are the gold particles. So they have nucleus with them. So these are the gold particles, and these gold particles are present in the gold foil. These gold particles have these alpha particles to be incidented on them. So these alpha particles fall on the gold particles. What happens? Let us see. Now you can see these alpha particles falling on the gold foil. This is the gold foil. So when these alpha particles fall on the gold foil, you can see that each and or most of the particles, they pass through in the straight line. See, this is straight line, this is straight line, again straight line, straight line. You can see most of them, they passes through the straight line. No need to worry. They do not change their path and pass straight line. But look at this, what happens? Look at this particular alpha particle. What happens? This alpha particle was coming in this direction. Actually, he has to, or the particle has to go in this direction, but this particle moves in the other direction this way. So instead of coming in this direction, my dear students, the alpha particle is deflected. And the alpha particle is deflected to certain angle. What is this angle? This angle is a very small angle, you can see here. And they are deflected in a very small angle. So most of the alpha particles, they have gone through directly. A very few particles they have deflected. You can see that they are deflected. And some of them are rebound. You can see them. They came into the same side as they were going. Or you can see here in this case, or sometimes what happens, they just come with the same line as they have gone. So once again, if you read now, you will come to know more about them. Let's have a text once again, or let us look at the various various observations that the Rutherford did. In the experiment, Rutherford allowed the fast-moving alpha particles to fall on the 1000 atoms thick gold foil. The following observations were made. First, most of the fast-moving alpha particles passed straight through the gold foil. Second, some of the alpha particles were deflected by the foil by a very small angle of deflection, and surprisingly, out of 12,000 alpha particles, one particles appeared to be rebound, coming back into the same direction or in the same medium. This is what it was observed. Let's look at the next question. Explain each observation with reasoning and conclusion for the Rutherford experiment or Rutherford's alpha particle scattering experiment. So now, following are the reasoning or the conclusion for the each observation given by the Rutherford for its alpha particle scattering experiment. So this reasoning or conclusion means, what do we understand from this observation? That is what we can say. So first observation was, most of the alpha particles passed through the gold foil without deflected. What do we understand? We understand that most of the space inside the atom is empty. So these particles, when they fall on the atom, there is nothing to stop them, and that is why they go or they pass through the straight line. Second observation, some of the alpha particles were deflected by the foil with a small angle. So positive charge of the atom occupies a very small space inside the atom. That is what it was understood, that in an atom, these alpha particles were deflected. So there was some positive charge available inside the atom that makes this alpha particle to deflect. But these alpha particles, or the number of particles deflected, is very small, and that is why inside the atom, the place or the space that occupied by the positive charge is very small. Then we have the next observation, that is the third observation. 1 out of 12,000 particles appeared to be rebound. Rebound means the deflected by 180 angle. So all the positive charge and mass of the gold atom were concentrated in a small volume within the atom. So as my dear students, we or the scientists have observed that only a very few of them, they come back in the same direction as they have gone. That is what it is the case that is observed, and when it was observed, the scientists or Rutherford concluded that all the positive charge of an atom all the positive charge and mass, I'm talking about this one, all the positive charge and mass of the gold atom were concentrated, means collected in a small volume within the atom. So once again, the positive charge occupies a very small space inside the atom and they are collected in a very small space. Now the next question, my dear students, what is nucleus? And compare the radius of nucleus and radius of an atom. So first let us define what is nucleus. There is a positively charged center in an atom. Nearly all the mass and all the positive charge are concentrated in this center. Such a center is called the nucleus of an atom. Once again, there is a positively charged center in an atom. Nearly all the mass and all the positive charge are concentrated in this center. Such center is called nucleus. Once again, please learn this definition. There is a positively charged center in an atom. Nearly all the mass and all the positive charge are concentrated in this center. Such a center is called nucleus. The radius of the nucleus is about 10 to the power 5 times less than the radius of atom. Once again, the radius of the nucleus is about 10 to the power 5 times less than the radius of the atom. So if we compare the radius of the nucleus and radius of the atom, then the radius of the nucleus is 10 to the power 5 times. That means 1 lakh times less or 1 lakh times smaller than the radius of nucleus. So if we say if 1 centimeter is the radius of nucleus, then the radius of the atom is 1 lakh centimeter. That is what it is, 1000 meter. So this is how, my dear students, we understand the difference or comparison between the radius of an atom and radius of the nucleus. Write the points of Rutherford's nuclear model of an atom, or write the features of the nuclear model of an atom of Rutherford. So now what information do we get about the atom from the Rutherford's model? Let us see it point-wise. On the basis of his experiment, Rutherford put forward a nuclear model of an atom. Rutherford's nuclear model has the following features. Number one, there is a positively charged center in an atom. Nearly all mass and all positive charge is concentrated in its center. Such a center is called nucleus of an atom. The electrons revolve around the nucleus in a circular path. And third, the size of nucleus is very small as compared to the size of an atom. So this is the information that Rutherford gave about the structure of atom. Once again, in the first point, Rutherford says that there is a positively charged center in an atom. Nearly all mass and charge of the particle of the atom is concentrated in the center of the nucleus, and this center of the atom is called nucleus. Electrons revolve around the nucleus in the circular path. Please remember that he has clearly mentioned that the electrons revolve around the nucleus in the circular path. And third one is the size of the nucleus is very small as compared to the size of the atom. Then, my dear students, we need to study about the drawback or the limitations of the Rutherford's model. So let us study the drawback or limitations of the Rutherford model. Rutherford, by his model, proposed that the electrons revolve around the nucleus in a circular path. That is what we have seen, just that Rutherford suggested that the electron revolve around the nucleus in a circular path. An electron is a negatively charged particle. Any particle in a circular orbit undergoes the acceleration, and during the acceleration, a charged particle will radiate energy. So this is a general rule, my dear students, that if any charged particles revolve in a circular path, this charged particle has to radiate energy. Electron is a charged particle which is having a negatively charge, and that is why when this electron revolves in a circular path, it has to radiate energy. Thus, if electron revolves in a circular path, it would radiate energy. Thus, it would lose energy and finally falls into the nucleus. So we cannot expect nucleus moving in a circular path this way. But instead of it moving in a circular path around the nucleus, actually what happens? The electron moves in this manner. Because it is a charged particle, it radiates energy, and that is why it loses energy. As it loses energy, it moves towards the center of the nucleus, and at one time, the electron falls inside the nucleus. So if the electron is revolving around the nucleus in a circular path, the electron being charged particles can never move around the nucleus in a circular path, and it should follow into the nucleus, and thus the atom should not be stable. But the atom is stable. Let us read. If so, means if electron is revolving around the nucleus in a circular path, and if electron is a charged particle, an atom cannot be stable, but atom is stable. So what Rutherford proposed was wrong. That means Rutherford made a mistake by saying that the electrons revolve around the nucleus in a circular path. Electron cannot revolve around the nucleus in a circular path. Please remember that according to the scientists and various experiments, it is being proved that if electron revolves around the nucleus in a circular path, it cannot revolve around the nucleus in a circular path, and the path of electron should be a spiral path. So electron will revolve around the nucleus not in a circular path. That means whatever the Rutherford has proposed that electrons revolve around the nucleus in a circular path is wrong. That was the biggest drawback of our Rutherford's model. Otherwise, Rutherford said that an atom has a nucleus. It was correct. Most of the mass and charge of the atom is concentrated into the nucleus. That is even correct. And the size of nucleus is very, very small than the size of an atom. That point is also correct. The only mistake found with the Rutherford model was that he said that electron revolves around the nucleus in a circular path, but electron cannot revolve around the nucleus in a circular path. Who put forward a new model in order to overcome the objections raised against the new Rutherford model? So then, to know about the structure of atom, new scientists came and they have proposed some model. In order to overcome the objections raised against the Rutherford's model of an atom, Niels Bohr, please remember, Niels Bohr put forward some postulates about the model of an atom. So the scientist Niels Bohr was there to propose the new model for the atom. He did not do any experiment. Please remember that the scientist Niels Bohr, he did not do any experiment. Instead of doing any experiment, my dear student, he gave us the postulates. Now, do you know what is postulates? Can any of you answer me? What is the meaning of postulates? Please reply, my dear students. Okay. I think you don't prefer to reply. Let me explain you. See, in mathematics, we have theorems. So, and then we prove them. So we have proof. But some of the sentences, some of the things that we do not give proof of, we don't give proof for. But we accept them as a truth. We accept them as true. Such things are known as postulates in mathematics. So postulates are, you can say in Hindi that they are the abhidharana. They are just, you suppose something and you believe it as it is a true. Such things are known as the postulates. So postulates do not have the experimental evidences. Please remember that these postulates do not have the experimental evidences. Please remember, my dear students, that postulates do not have experimental evidences. So this is how, my dear students, these postulates were given by the scientist. His name was Niels Bohr. So now the question is, write the postulates of Bohr's model of atom. What postulates did Bohr give about the structure of an atom? Let us look into that. So let's read all those postulates and try to understand that. In order to overcome the objections raised against the Rutherford's model of an atom, Niels Bohr put forward the following postulates about the model of an atom. Only certain spatial orbits known as discrete orbits of electron are allowed inside the atom. Please remember that only certain spatial orbits. See, he used the word spatial orbits, but he did not specify what spatiality were there. But then he said only certain spatial orbits, then give them name as a discrete orbits. Only certain spatial orbits known as the discrete orbits of electrons are allowed inside the atom. Second, while revolving around, while revolving in a discrete orbits, the electron do not radiate energy. So when these electrons are moving in the orbits which are not circular in shape, they do not radiate energy. These orbits or shells are called energy levels. He gave them the name as energy levels, or our Rutherford, or sorry, Niels Bohr called those orbits or those shells as energy levels. These orbits or shells are represented by the letters K, L, M, and N. The numbers n is equal to 1, 2, 3, 4, and they are also represented by the number n is equal to 1, 2, 3, 4, and so on. Please understand, my dear students, that the one which is nearmost to the nucleus is given n is equal to 1. Then the next one is called n is equal to 2. Then the next one is called n is equal to 3. Then the next to n is equal to 3 is called n is equal to 4. And same way as we move over or as we move away, we can have the various others also, and we can give them the numbers accordingly. So this n is equal to 1 is called K shell, the n is equal to 2 is called L shell, n is equal to 3 is called M shell, n is equal to 4 is called N shell. If you have n is equal to 5, then you can call it as a O shell, K, L, M, N, O shell. Let's say it is n is equal to O shell, where you have n is equal to 5. So this is how, my dear students, we understand the model which was given by the scientist. His name was Niels Bohr. So my dear students, we stop the class for today, and I hope you have enjoyed the class. I wish you happy learning.